Algebra 2, welcome back. Here is section 14.1b, where we will graph the cosine function. And something special is that this is our last video. Woo, we've made it. We are finally done with this semester and this year. Okay, you're there. All right. Just gotta stay with me for another week as we review and take our final, and then we can finally just take a break, right? Finally have some time to ourselves. Okay, so let's go ahead and finish up this chapter 14 stuff strongly, okay? So our objectives are to graph the parent cosine function and then review characteristics of the sine function, okay? Today's gonna be pretty easy in a sense that it's almost the same as what we did in 14.1a. The only difference is we're doing it with cosine, and so the values are gonna look a little different, right? So just like we did with sine, let's kind of start off the same way. We're going to graph the function f of x is equal to cosine of x. Okay, and so the inputs we want to choose, just like with the sine function, we're going to want to choose that from our unit circle. Okay, so let me see if I can draw a better circle than I did in the previous video. Chances of that are slim, but let's see. Okay, that's a little better, right? This previous video was kind of a little worse, so this one is a little bit better. Okay, let's go ahead and label the points that we want and the angles that go with them. So just like with the sine function, we're going to want to use 0, pi over 2, pi, 3 pi over 2, and then all the way up to 2 pi, right? Whatever we call the points we're going to come up with here in a little bit, we call those the quarter points, because those are kind of the important ones. Those kind of give us the shape of our graph. And so let's also write down these ordered pairs that are associated with those angles. Here we have 1, 0, 0, 1, negative 1, 0, and then 0, negative 1 down here. Okay. So we're going to do the same thing we did. We're going to evaluate our function at each of those angles. So we're going to do f of 0, f of pi over 2, f of pi, f of 3 pi over 2, and then f of 2 pi. And of course, we can keep going, but we know that this is enough to complete one cycle, one period of the function, the parent function at least. And so it'll just end up looking the exact same, right? So f of 0, that's going to be cosine of 0. Cosine of 0, it's all the x values, right? So in this case, we're going to actually start off with 1. Okay, if you remember sine started with the y value of 0. Cosine of pi over 2, that is 0. Okay, and then cosine of pi, that is chilling over here at negative 1. Cosine of 3 pi over 2, 0. And then cosine of 2 pi all the way back to 1. Okay, looking nice. We can convert these into ordered pairs, right? Because this is my x value, this is my y value. So I have 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and then 2 pi, 1. All right, and so that's kind of what we had, why we had last time, that step-by-step process of how to get the x values and the y values of our quarter points, because then otherwise we'd have to do this by hand every single time. Whereas doing the increment and then multiplying our y values by the a lot easier than kind of doing this by hand for every single cosine function, right? Now, for some of us, this might make more sense. But as you can see, it's kind of tedious and takes a little bit of time, right? So then now let's go ahead and just kind of graph a quick little picture of this, okay? So we'll just kind of do this. I don't need to go that far down. We can stop right there. Okay, so 1, negative 1. Here we have pi halves, pi, 3 pi over 2, and then 2 pi. And now we can plot our points. So we have 0, 1, pi over 2, 0, pi, -1, 3 over 2 pi, 0, and then 2 pi, 1. And so our cosine function, the graph, looks like this. It's going to have kind of the same shape as the sine function. It has this kind of periodic shape, right? This wave pattern. And I'm just going to keep going to show you that it just constantly repeats itself in this like up and down wave motion. The only difference is that sine, if you remember, I'm going to draw the sine graph in red. It started at 0, and then it made that pattern. So pi over 2, 1, pi 0. Okay, so here is the sine function in red. Okay, you don't have to include this, but you can if you kind of want to see the difference between the two. Okay, notice how they're kind of just shifted, right? It's the same picture, just shifted to the right a little bit. If it kind of looks a little bit like DNA, like a little DNA strand, right? Not exactly that perfect, but you know, it kind of resembles that a little bit. Okay, so it has the same exact properties. It works almost the same way. The only difference is that they start in different positions. Okay, and it's based off of the fact, based off of the unit circle. Okay, I'm gonna get rid of the red lines so we can leave our cosine graph there. Okay, and then just like we would normally do, we would label our quarter points. So 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and then 2 pi, 1. All right. Cool. So then just a little bit of review. We had some of these vocab terms. The amplitude, that was half the distance between the highest and the lowest point on the sine graph. So highest point is at 1, lowest point's at -1. The distance is 2, so then our amplitude is 1. Okay, remember this, the amplitude for sine was also 1. And then the period, you know, it's the length of one cycle of the, oh, I copied and pasted this, I have to be honest, and I forgot to change sine to cosine. Cosine, right, because it's the same thing. So you get it, right? Cosine, okay, length of one cycle. And so in this case, it's also 2 pi. Okay, the difference here is that a cycle on the cosine graph looks a little different, okay? It's the amount of time it takes, or the length of what it takes to start at 1, go down, and then come back up and end at 1 again, right? So in my opinion, it's a little bit clearer what a cycle on the cosine graph is, just because, you know, in this case, it starts at 1 and then it ends at 1 as well. Whereas for the sine, it starts at 0, it goes through 0 once, but then it comes back again to 0, okay? General form is the same, a cosine bx, and then all the other pieces of information are the same as well. Our amplitude is the absolute value of a, and the period is 2 pi divided by the b value. All right, so let's go ahead and just practice with the cosine graph, okay? We're gonna find the quarter points the same way we did last time. Okay, graph one cycle of cosine of 3x, identify the period and amplitude, and label the 5 quarter points, okay? So remember, we wanna start by finding our amplitude and period. So we're gonna use that, we're gonna use a and b to find that. Our a in this case is 1, our b is 3. So what does that mean? That means our amplitude is 1, and our period is 2 pi divided by b, which is in this case 3. So our period is 2 pi over 3. Now how do we find our quarter points? Remember that for the x values, we need to take our period, divide by 4 to get the increment, and then increment the x values using that value that we get. Okay, so let's divide our period by 4. 2 pi over 3 divided by 4, which remember is the same thing as multiplying by 1/4. And I do it that way because we have a fraction as a period. Okay, so this 2 becomes a 1, this 4 becomes a 2. Multiply across, we have pi over 6 is our increment. Okay, so now we can make a little table of our x and y values. Okay, sorry, there's something under my desk that Leo is very interested in because he keeps coming on here under here to bother me. All right. Okay, So we're going to find our quarter points. We're going to start with our x. Now our x is affected by the b. Our b equals 3. And how is that affected? Well, now our x is going to increment by pi over 6. So we're going to start at 0 still. And then the next x value, we're going to add pi over 6. So that's just going to be pi over 6. And then the next one, we're going to add pi over 6 to pi over 6, which is 2 pi over 6. But that's just pi over 3 when we simplify it. Okay, the next one, 2 pi over 6 plus pi over 6 is 3 pi over 6. That's pi over 2. And then the last one is 3 pi over 6, right? Because that's 3 pi over 6 in disguise, plus pi over 6, which is 4 pi over 6. And that's going to be 2 pi thirds. And we know we did that correctly because we should always end with whatever our period is, since we're starting at 0. Okay, to get the y values, we multiply the original ones by whatever our a is. In this case, a is 1, so we don't need to do anything. We're just going to take our original y values of 1, 0, negative 1, 0, 1. Okay, so 1, 0, negative 1, 0, 1. Those are our original ones. Okay, and so now we graph. And what I'm going to do is I'm going to try to give us a good idea of what this looks like in comparison to the parent cosine function. So I'm going to go all the way out to 2 pi just to show you the kind of comparison. So 1, 2, 3. Okay, so if I do this correctly, pi over 2, pi, 3 pi over 2, 2 pi. So 2 pi is here. Okay, I don't really care about these other two, but I do care about this one being pi over 2. Because that's part of our increment, right? That's one of our x values, one of our quarter points. Okay, and so we're going to end up at 2 pi over 3. We know pi is right here. So 2 pi over 3 is actually going to be, if I divide this up correctly, right about here is our 2 pi over 3. And then our pi over 3 and pi over 6 is right here. So pi over 6, pi over 3, pi over 2, 2 pi over 3. Okay, and we know that these always have to be the same distance away from each other, right? Because that's the point of our quarter points. They cut up our graph into 4 equal pieces. Okay, and so now we can graph our ordered pairs. Okay, 0, 1. We're going to put 1, forgot to do that, 1 and negative 1. So 0, 1, which is right here. Pi over 6, 0. Pi over 3, negative 1. Pi over 2, 0. And then 2 pi over 3, positive 1. So here's our graph in green. Okay, there's our new cosine graph, the one that we're graphing based off of this function we were given. And then our original graph, and do that in like this little purple color. Remember that our original graph here is pi. Actually, I guess I do care about these after all. Our graph originally would have been here's 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi 1. Make that a little bit nicer. There is an original cycle of the graph. Okay. And so notice how, I don't know if you've been kind of noticing with the other graphs, if this B, the bigger it gets, the more squished down our transformed graph becomes, right? And the smaller it gets, the wider it's going to be. Okay, that's kind of the effect that this B has on our graph. Okay, and then the last thing we got to do is label our quarter points. I'm gonna have to squish them in here a little bit. So 0, 1, pi over 6, 0, and then pi over 3, negative 1, pi over 2, 0, and then last one is 2 pi over 3, 1. Okay, so we're all set with this one. Let's do one last one to close it off. All right, graph one cycle of f of x equals -2 cosine of 0.5x. Okay, we're going to do the same thing as we did in the previous one. Okay. So then let's go ahead and start by identifying our a and b. And so our a is -2. And our b, I'm actually going to, this is 0.5, but I'm going to write it as the fraction, 1/2, okay? The only reason why I did it here like that is because I can do the fraction typing. So this is also -2 cosine 1/2 x, okay? So there's my a and b. So that means my amplitude is going to be +2, right? Because I take the absolute value of the a. So absolute value of -2, that gives me +2. And then my period is 2 pi divided by 1/2. But that's the same thing as 2 pi times 2/1, right? If I'm dividing by something, I can multiply by the reciprocal. So I end up getting 4 pi as my period. So then my increment for this one is going to be 4 pi divided by 4, which is going to be pi. So that's our increment for this one. That's a nice and easy increment, right? Okay, so let's go ahead and find our quarter points. Okay, so our x and y. Our b is 1/2, and so that's going to influence our x values because now my increment is different from the original. So 0, pi, 2 pi, 3 pi, and then 4 pi. Nice and easy, right? That's a pretty nice increment. And then a is -2. So I multiply all my original values by -2. So originally I had, my original ones are 1, 0, -1, 0, 1. So multiplying those by -2, I get -2, 0, 2, 0, -2. Okay, so then now I can graph. Okay, and so I don't think I can, let's see. Yeah, I won't be able to fit the whole thing. So we'll just we'll do it with the space we have. So right up to here is our 2 pi. I just like to make things nice and even for you to see the differences between the ones we've graphed before. So 2 pi, 3 pi over 2, except I'm dumb and we're supposed to be going all the way up to 4 pi. So this is 4 pi. I apologize, I'm not thinking clearly here. There we go. So 4 pi, 3 pi, 2 pi, and pi. And then we have a 2, -2. Okay, so let's graph it in orange. We have 0, -2, pi, 0, 2 pi, +2, 3 pi, 0, 4 pi, -2. So in orange is our transformed graph. Yikes, I'm having a little bit of a hard time here connecting these dots. The easiest thing to do, right? There we go. Okay, and then I'm gonna draw for you in green the original graph, right? Remember, we start at 1, and then here's pi over 2, here's 3 pi over 2. Kind of looks like this. Here's the original cosine graph. Okay, so notice now that I have a smaller b, my transform graph became a lot longer. I kind of stretched it out horizontally, but then I also had to reflect it. Notice how it's going to go in the opposite direction. Here it starts up, goes down, then up. Here it starts down, goes up, and then back down. And then it's also stretched out vertically, right? It's a lot longer vertically wise. Vertically. Making up words here. All right, so there's our graph. Last thing we have to do to close this off and put a nice little bow on it is label our quarter points. So this one is pi 0, 2 pi 2, 3 pi 0, and then 4 pi -2. It is finito. We are done. Last thing for this semester in terms of content, nice and easy, I think, because we did a lot of this with sine already. So yeah, I hope this sounds good. Ask lots of questions this next week as we start reviewing for our final. Okay. I'll see you in class. I was gonna say I'll see you in the next video, but I won't. Thanks for sticking around.